How did the Israeli Air Force fly thousands of miles to Qatar to carry out a targeted strike on Palestinian negotiators in Doha? Tonight we break down the who, what, when, where, and how of that operation step by step. The target was a residential building in Doha's Qatar district, reportedly hosting senior Palestinian Pilot Bureau members. 5 buildings stood in a row, with a petrol station adjacent, and the strike hit only the middle building precisely. Around 10 precision guided munitions were reportedly used and launched nearly simultaneously at that building. Possible weapon types mentioned include GPS guided bombs, laser guided munitions, and long range glide weapons used in combination. The central question is simple and unsettling: how did attackers know which building to hit and when the meeting would occur? Since October 7th, heavy security, including a permanent guard presence around that structure, made the location stand out. That visible security detail was a clue indicating high-profile occupants and regular meetings inside the complex. Qatar's role as a host for Palestinian political and militant leadership creates both diplomatic cover and security challenges. Intelligence assessments say multiple collection methods were combined to identify the target and timing. Those methods reportedly included human intelligence signals, intercepts, aerial and satellite surveillance, and cyber tools. Cross-checking layered intelligence allowed precise targeting that minimized uncertainty over which building to strike. Technically, the mission was difficult because Doha is roughly 1,200 miles or about 2,000 kilometers from Israel. That distance is beyond the combat radius of fully armed Israeli fighters without mid-air refueling. Mid-air refueling from aerial tankers was therefore essential to extend range loiter time and allow a safe return. Reports suggest roughly a dozen to 15 fighters participated, supported by aerial tankers for refueling en route. Discrete refueling was likely conducted over international or third-party airspace to reduce radar exposure. Around mid-afternoon, the strike package reportedly arrived over Doha and launched precision munitions nearly simultaneously. The operation emphasized speed timing and an extraction plan to avoid prolonged engagement or escalation. Stealth aircraft like the F-35 with advanced low observable features likely played a leading role in penetration. Stealth plus electronic countermeasures make detection and tracking by conventional air defenses far more difficult. Supporting F-15s and F-16s likely provided airspace security while reconnaissance assets fed real-time intelligence. The combination of stealth strike platforms supporting escorts and tankers illustrates complex mission choreography. After the strike jets disengaged, refueled, and returned to base, minimizing time in hostile or monitored airspace. A separate case study shows an even more destructive method where many bunker-penetrating weapons were used on a multi-story block. Analysts discuss 3 hypothetical scenarios that could lead to such an intense concentrated strike. Scenario 1 posits a timely tip from an external agent providing precise coordinates and arrival information. Scenario 2 envisions on-the-ground confirmation or laser designation by covert operatives enabling pinpoint delivery. Scenario 3 suggests long-term signals, exploitation or hacking of communications to reveal exact timing and location. In each scenario, overwhelming firepower is employed to ensure elimination of a high-value target at the cost of heavy collateral damage. Weapons named in open reporting include bunker-penetrating munitions, glide weapons, and Mark series freefall bombs fitted with guidance kits. A high-level engineering overview explains how modern guided glide munitions marry inertial systems with GPS or laser cues for accuracy. Glide kits and wing assemblies extend range, while guidance units and thermal batteries power control surfaces and flight computers. These systems provide standoff options that allow aircraft to release weapons from safer distances or altitudes. Bunker-penetrating warheads are built to survive initial impact and detonate after penetrating reinforced structures. Delayed fuses and hardened casings increase effectiveness against subterranean spaces and reinforced concrete bunkers. The result is a capability to reach protected underground facilities while causing widespread structural collapse above ground. Such operations raise acute legal, strategic, and humanitarian questions about proportionality and civilian risk. From a purely technical view, long range precision strike requires integrated intelligence, logistics, tanker support, and electronic warfare measures. The political layer is equally complex because strikes in third party states risk diplomatic fallout and regional escalation. Cases like these also illustrate how modern conflict blurs the line between intelligence collection and kinetic action. For engineers and analysts, the weapons and delivery systems offer a study in trade offs between range, payload, and accuracy. For policymakers and citizens, the episode highlights the urgent need to protect civilians and preserve diplomatic channels.